So today with 5.2 notes, we will be adding, subtracting, and multiplying polynomials, as well as look at binomial expansion using Pascal's triangle, which is what the handout is for. So the adding, subtracting, and multiplying is something that you should already know from Algebra 1. If we look at our first example, we've got in parentheses 3y cubed minus 2y squared minus 7y plus, in another set of parentheses, you have negative 4y squared plus 2y minus 5. So what you're going to do is rewrite this problem without the parentheses. So I copy down the 3y cubed minus 2y squared minus 7y. And then when I have the plus negative 4y squared, at no point should we have a plus negative. We will jump straight to minus 4y squared plus 2y minus 5. And then, once we remove those parentheses, all you have to do is combine like terms and put your answer in standard form, which is your highest exponent down to your constant. So if we start with that, we start with 3y cubed. That has nothing to combine with, so it gets copied down. Then we have negative 2y squared minus 4y squared to give you negative 6y squared. Then we have a negative 7y plus 2y, which is a negative 5y minus 5. And that would be our answer. So when you are subtracting polynomials, then if I have the example in parentheses 8x cubed minus x squared minus 5x plus 1 minus, in parentheses, 3x cubed plus 2x squared minus x plus 7. When you're subtracting, you're still going to copy down the first polynomial, that 8x cubed minus x squared minus 5x plus 1. But then when you are subtracting, you are distributing the negative to every term inside that second set of parentheses. So the entire second polynomial will take on that negative, so it becomes a minus 3x cubed minus 2x squared plus x and minus 7. Then once you're able to, once you distribute, then you're able to combine like terms in standard form. So 8x cubed minus 3x cubed gives you 5x cubed. Then negative x squared minus 2x squared is a negative 3x squared. Then you've got negative 5x plus x to give you a negative 4x. And 1 minus 7 gives you negative 6. And that would be your answer. So for adding and subtracting, you'll rewrite it. Subtracting, you'll distribute the negative and then combine like terms. Okay? So for multiplying polynomials, you are already familiar with FOILing. So if I gave you x plus 3 times 2x minus 1, you should already know to take your x, you multiply it by 2x, then you multiply it by negative 1, then you take the 3, multiply it by 2x, multiply it by negative 1. Multiplying polynomials is the same concept. So if I look at the first example, I have x minus 2 in parentheses, and then that's being multiplied by negative 2x squared plus 3x minus 6. So I will take this x and I will multiply it to each term in parentheses. So x times negative 2x squared is a negative 2x cubed. X times 3x is 3x squared. X times negative 6 is a negative 6x. Then I'm going to take the negative 2 and multiply that to each term in the second polynomial. And so negative 2 times negative 2x squared is a positive 4x squared. Negative 2 times 3x is a negative 6x. Negative 2 times negative 6 is a positive 12. Then from that point, I'm done multiplying. I can combine like terms and put it in standard form. So I have a negative 2x cubed 3x squared and 4x squared gives me 7x squared. Negative 6x minus 6x gives me negative 12x. Then I bring down the plus 12. Okay, now you could have something that's a little bit larger than that. So if we have a trinomial times a trinomial, then you're going to have a little bit more to multiply. So I've got 2x squared plus 3x minus 1 times 3x squared minus 4x minus 2. So I'm going to take the same concept. I take my first term, 2x squared, multiply it by everything in that trinomial. Take my 3x, multiply it by everything in this trinomial. Take the negative 1, multiply it by everything in that trinomial. So I end up having 9 terms. So 2x squared times 3x squared gives me 6x to the 4th. You are adding those exponents. And then 2x squared times negative 4x is a negative 8x cubed. 2x squared times negative 2 is a negative 4x squared. Then 3x times 3x squared is a 9x cubed. 3x times negative 4x is a negative 12x squared. 3x times negative 2 is a negative 6x. Then distribute the negative 1, and that gives me a negative 3x squared plus 4x plus 2. And then at that point I am able to combine like terms in standard form and bring down my 6x to the 4th power. Negative 8x cubed plus 9x cubed gives me just 1x cubed. Negative 4x squared minus 12x squared minus 3x squared gives me negative 19x squared. Then I have a negative 6x plus 4x, which is a negative 2x plus 2. And that would be my answer. Okay? So we can also look at if you have 3 binomials multiplied. So if I have x minus 5 times 3x plus 1 times negative 2x minus 3. Okay, you can't multiply all 3 of these together at the same time, but you can choose 2 of them. You can either choose the first 2 or you can choose the second 2, the last 2. What I personally do is like to have mine set up as a binomial times a trinomial, so I will copy down the x minus 5 and I will multiply 3x plus 1 with the negative 2x minus 3. So that gives me negative 6x squared minus 9x minus 2x minus 3. And then I clean that up and combine my x terms, so negative 6x squared minus 11x minus 3. And now I can do the multiplication with my x and the negative 5. So that becomes negative 6x cubed minus 11x squared minus 3x plus 30x squared plus 55x plus 15. So when I combine like terms, that's going to leave me with negative 6x cubed, negative 11x squared plus 30x squared is 19x squared, negative 3x plus 55x is 52x, then plus 15. Okay, so if we look at our next section, these are special product patterns that you can either use the pattern that I go over, or you can still just take your time to multiply. So if we look at a sum and difference, that is if I have 2x plus 3 times 2x minus 3. So at this point you would just FOIL that, but you should recognize that these two are conjugates, and we used conjugates when we had to rationalize square roots or when you had to rationalize with a denominator with I. So your conjugate formula tells you that if you have a plus b times a minus b, that will equal to a squared minus b squared. So I am taking the first term and squaring it, taking the second term and squaring it. I no longer have a middle term because those two would cancel out. So if I have 2x plus 3 and 2x minus 3, and I recognize that those are conjugates, then I can take 2x and square it to give me 4x squared minus 3 squared, which is 9. Or if you want to take the time to FOIL it, you can do that as well. Okay, the square of a binomial tells me if I have any binomial squared, then I can use a formula. So what we're going to look at is x minus 3 squared. My formula says if I have a plus or minus b squared, then I can take that a squared plus or minus 2ab plus b squared. So what that means is if I had a plus b times a plus b, and I FOILed that, then I would have a squared plus ab plus ab plus b squared. Those two ab's is where the 2 comes from in the formula, because you are writing the same thing twice typically, and FOILing you will have the same 2 middle terms, so we just multiply the 2 terms together and double it because of this right here. So if I have x minus 3 squared using my formula, I would take x and square it. I would keep the sign. 3 times x would be multiplied to give me 3x, and I would double that to get 6x, and then plus 3 squared is 9. But again, if you need to write it twice and FOIL it, you can do that also. Okay, now with the cube of a binomial, I have 3x plus 2 squared. And if I have 3x plus 2 cubed. So if I have 3x plus 2 cubed, we know we need to write that 3 times and multiply. So there isn't really a shortcut here. Once you write it 3 times, then the only thing really that you can do is use the square of a binomial pattern right here. So I'm going to copy down the 3x plus 2, and I'm going to recognize that this is the square of a binomial. So I'm going to take 3x and square it, giving me 9x squared. Multiply 3x times 2 to give me 6x, and then double it for 12x, and then plus 2 squared is 4. Then from there I would multiply. 3x times 9x squared gives me 27x cubed. 3x times 12x gives me 36x squared plus 12x. Then I multiply by 2, and I get 18x squared plus 24x plus 8. And so that would give me 27x cubed plus 54x squared plus 36x plus 8. Okay? So, what we will look at now in this last section is if I take a binomial and expand it further. So Pascal's triangle allows you to use a pattern to expand any binomial to any degree. If I do not say use Pascal's triangle in the instructions, I expect you to treat it similar to what we did up here, writing it, FOILing it, multiplying it. If I say use Pascal's triangle, and then you are able to use the pattern. But if you use it in the wrong section where it doesn't say, you will lose credit. So make sure you are following what your instructions tell you and doing the proper steps in the proper section. Okay, so here in the handout that we have, this is showing you that you could take any binomial a plus b, where a could be any term and b could be any term, and you can raise that to any power. The handout just goes to the 5th power, but you can really do any power that you want if you learn the pattern of the expansion. So if we have a plus b to the 0 power, anything to the 0 power is always just 1. If we have a plus b to the first power, anything to the first power is itself. There's your a plus b. If we have a plus b squared, that is the a squared plus 2ab plus b squared that we had just talked about with the square of a binomial. Once we get to higher degrees, then the pattern continues to get larger. A plus b cubed gives you a cubed plus 3a squared b plus 3ab squared plus b cubed. And it goes onward. You can read each one. Now, what's happening is in your pattern, if you notice, each term of your a, so I start with a squared, I go down to a, then it's not there. I start with a cubed, I go down to a squared, it's a, and then there's not one. Then I have a to the fourth, a cubed, a squared, a, there's no a. As I go throughout the problem, the power of a will start with whatever your degree is, and then it will decrease by 1 for each term to follow. As that decreases by 1, your b will start to increase. So I did not have a b here, so this is technically b to the 0, then b to the first, b second, b cubed. And it's going to end with whatever that exponent is. So if I raised it to the 5th, I have a to the 5th, my exponent decreases by 1, a to the 4th, while my b appears. And then I decrease a cubed and I increase b squared. Decrease a squared, increase b cubed. Decrease to a, increase to b to the 4th. No longer an a, but I have b to the 5th. Each term, the sum of the exponents will be equal to that original power. Okay, so once you get that pattern down, you don't have to memorize each individual row. You just have to know the pattern. Then we're going to look at the actual triangle. So Pascal's triangle consists of the coefficients of each row. So if you look, you start and end each row with a 1. So anything to the 0 power is 1. Anything to the first power was itself, so a plus b. And then from there, to build your triangle, each successive row, you're going to use the 2 numbers above it and add them to get the middle term. So I start with a 1, then I add 1 plus 1 to give me 2. End with a 1. Then my next row, I start with a 1, 1 plus 2 gives me 3, 2 plus 1 gives me 3, and then I end with a 1. My next row, I start with a 1, 1 plus 3 gives me 4, 3 plus 3 gives me 6, 3 plus 1 gives me 4, and then I end with a 1. And then my last row that I have on the paper, I start with a 1, 1 plus 4 gives me 5, 4 plus 6 gives me 10, 6 plus 4 gives me 10, 4 plus 1 gives me 5, and I end with a 1. So if you know how to build the triangle, it's easier than just memorizing, okay? What you will have to know is the pattern that your A's are decreasing as your B's appear. So let's put it together with our examples. If I have x minus 2 raised to the 5th power, I need to know what my coefficients are. So what I'm going to do is I'm going to write my Pascal's triangle on my paper. So I'm going to build it. We start with the first, and then we have 1 and 1. Then we have 1, 1 plus 1 gives me 2, and then 1. 1 plus 2 gives me 3. Then we have 3, and then we have 1. Then I have 1 plus 3 gives me 4, 3 plus 3 gives me 6, 3 plus 1 gives me 4, and I end with a 1. Then I have a 1 plus 4 gives me 5, 4 plus 6 gives me 10, 6 plus 4 gives me 10, 4 plus 1 gives me 5, and then I have a 1. So this is 0 to the 0 power, the first power, the second power, third, fourth, and then fifth power. Okay? So if I am taking x minus 2 to the 5th power, that means my coefficients are 1, 5, 10, 10, 5, and 1. Okay, so I'm going to have 6 total terms here. My A in my handout refers to the first term. My B refers to the second term. So A is equal to 6 and B is equal to negative 2. So here, if you want to write that 1a to the 5th plus 5, because you're using the second coefficient, your a decreases to 4 while your b increases by 1. And then plus your 10, a decreases to 3 while b increases to squared. Then I have my 10, a will decrease to squared while b increases to cubed. Then plus 5, a will decrease to 1 while b increases to 4. And then plus 1, there's no longer an a, and I just have b to the 5th. You do not have to write this, but if you need to see the simplified a and b, you can. Okay, what I expect to see is you do this, but in terms of the problem. So we're going to have our first coefficient, and our first term, which is x, is going to be raised to the 5th power. Then we're going to take our next coefficient, 5, and I'm going to decrease x to the 4th power while my second term, negative 2, appears because it increased by 1. Then I take my next coefficient, which is 10, and I take x and reduce it by a degree, so it's x cubed. Then that negative 2 now has an exponent of 2. And then I'm going to take my next coefficient, which is 10 again, and I reduce x by another degree, so x squared, and I increase negative 2 by another degree, so negative 2 cubed. Then plus 5, I take x, it's decreased to 1, and then negative 2 is increased to 4. And then plus 1, I no longer have an x, I just have negative 2 to the 5th power. So that's what I'm looking and checking. From there, I'm going to clean it up. If I have 1x to the 5th, that is just x to the 5th. When I have these terms, I'm going to multiply 5 times x to the 4th times negative 2. So 5 times negative 2 is negative 10, and I have x to the 4th. Then my next term, I have 10 times x cubed times negative 2 squared. Negative 2 squared is a positive 4. Positive 4 times 10 is 40 x cubed. And then I have 10 times x squared times negative 2 cubed. Negative 2 cubed is a negative 8. Negative 8 times 10 is a negative 80 x squared. So each of these x's should be in standard form, x to the 5th, x to the 4th, x cubed, x squared, and now I'm looking at x. So I have 5 times x times negative 2 to the 4th power. If you have trouble with your exponents, then you can write, I'm going to try to do it with the glare. How you have it written is how you can type it just without the x. So if I'm doing 5 times negative 2 to the 4th power, write it in, how you write it is how you type it, and you get a positive 80 as your coefficient, and then x gets tacked on. And then my last term, negative 2 to the 5th power, is negative 32. Okay? So we're going to look at one more example like that. If I have 3y plus 1 cubed, it's to the 3rd power, so my coefficients for my triangle would be 1, 3, 3, 1. Okay, so I'm going to take that first term, and a will be raised to the 3rd power, plus a coefficient of 3, a reduces to square, while b increases to up to 1. And then I have 3 again, a decreases to 1, b increases to squared. And then I have a 1, b increases to cubed. So, let's apply it. A is 3y, b is 1. So I have 1, and my first term, 3y, has a power of 3, plus my coefficient of 3. 3y is now reduced to squared, and now the b term, which is my second term of 1, increases. Then I have my third coefficient of 3. 3y decreases to an exponent of 1, and 1 now has a power of 2. And then my last coefficient of 1, 3y disappears because it's to the 0 power, and 1 is to the 3rd power. So when we simplify 3y cubed, I have to also cube the 3, not just the y. So that gives me 27y cubed. Then I have 3 times 3y squared times 1. So again, if you need to use your calculator, I have a 3 times 3 squared times 1. Gives me 27y squared. And then if I need to do it again, 3 times 3, this is now times 1 squared. That gives me 9y. And then 1 cubed is just 1. So, as long as you have the pattern of decreasing your first term and increasing your second term, then you should be okay with the pattern as long as you can also build this triangle. Okay, so you will have a quiz over this. If you have any questions, let me know.